Here is your Unit 10 4.0 practice video. The first question on the 4.0 practice says the monthly cost to rent an apartment has increased from $350 to $550 in the last 4 years. Assume that the rent value is growing exponentially with time. Find the growth factor. And so when we're doing this, we are talking about using this function. Oh, sorry, erase that. Y equals ABX, where Y is your new value, A is your initial value, B is your growth or decay factor, and X usually represents time. And so if our new factor, or our new rent is $550, and our original was $350, we're looking for B, looking for that growth factor, and it's been going on for 4 years. And so I'm just solving for B here. And so I'm going to start by dividing both sides by 350. And that will give me $1.57 equals b to the fourth. And then I'm going to actually take the fourth root of that. Which is 1.12. And so that would be my growth factor, which means that it's growing at 12% each year. So if this growth rate continues, what will be the rent in 5 years? And so we have Y equals, we have our original amount, we have our growth factor, raised to, I guess I should probably show that work up there, sorry. Raised to the 9th power, because it's already been 4 years have passed, and then we're wanting 5 more to pass. And so, figure that real quick, and we get $967.68. Okay, question 2 says you bought a house for $82,000. You were able to sell it 10 years later for $70,000. Assume that the resale value of the house decays exponentially with time. To the nearest percent, what has been the average annual decay rate in value? So we're going to do the same thing that we did on question 1, but this time not only are we finding the decay rate, we are finding the percentage of decay as well. So we're going to set this up the same way. We have our new value equals our original value times our decay rate raised to the 10th power. So we're going to start by dividing both sides by 82,000. Which gives us 0.85. And then we are going to 10th root both sides. And that gives us 0.98 as our decay rate. So that's our decay rate, but our decay percentage, I guess this is our decay factor, sorry. This is our decay factor, but our decay rate, our percentage that we're looking for is how far away from 1 this is, and it's 2% away from 1. So it's decaying at a rate of 2% per year. If this decay rate continues, what will be the cost in 5 years? And so we're going to do the same thing that we did before. We're just going to do our original. We're going to use our decay factor, 0.98. We already know it at 10 years, so we're going to do 15 years. And then figure out what that is. So this would be in 15 years, it would be worth $60,562.67. So looks like they need to sell it quicker or sooner rather than later in this situation. Okay, last situation or last question on here is solving equations. So there's a couple of different ways that you can look at this. So first of all, what I like to do is I like to just take the log of both sides. And then that power rule tells us that we can move the power out in front on both of these. So we end up with 5x minus 1 times log of 2 equals x plus 3 log of 5. And then I distribute that log of 2, so I have 5x log 2 minus log 2 equals x log 5 plus 3 log 5. And the reason that I do it this way, if you talk to other teachers, they may do it differently, but I like to keep it as precise as possible till the very end. So I keep this like log 2, log 5 in there until the very end when we get our decimal. That way it's the most precise that it can be without rounding as we go. So now I'm going to move all my x's to one side. So I'm going to subtract x log 5 from both sides. And I'm going to add log 2 to both sides. Now, since 5x log 2 and x log 5 aren't like terms, we have to just write them separate. And same thing with 3 log 5 plus log 2. And I'm going to factor out this x. So I'm just going to pull that out on both. And then divide both sides by this set of parentheses. So this would be your answer, and now you can type it into your calculator. And since we just use log, you can just use the log button on your calculator. So 3 log 5 plus log 2. And then divided by, now let's put parentheses around the numerator and the denominator. So I got 2.97. So that would be your answer, 2.97. So that's A. We'll go ahead and do B on the next page since we ran out of room. Okay, so we're going to do the same thing. We're going to log both sides. This one will be a little shorter since there's not as much going on that right side. Pull that power out front. Distribute log 5. And then I'm going to move this over to the other side so my x's are on the same side. Cancels out. I'm going to go ahead and pull my x out of both parts here. And then divide by this. And then, so that's going to be my answer. And to find the decimal equivalent, we can use our calculator. And that's going to equal 1.12.